what I'm doing here is I'm simply going to test several HGP cards that they boot with 89 MHz HGP, because its frontside bus is now overclocked to 133 MHz, and that's overclock for the BX chipset, not for the CPU. That is Nehemiah here. I'm checking that this boot and that all of the memory can be accessed. I'm using Nexus VGA memory test. It's very new. I'll put link in the descriptions. Only one version has been released so far, and it's not really a bug on the tester, because it simply reads Visa information about memory size, but some of these cards reported incorrectly. So for some cards I can test all the memory, and for some cards I cannot. At least it gives some information that it is accessible at least, and with 89 MHz HGP. And the cards that are not compatible or shows any sign of errors, whatever, those I'm simply forgetting, and we'll look at those interesting cards later. Hello and welcome to build a system from the Asus P3B-F motherboard that has been seen recently on my previous videos. I actually have started this already because my first attempt for intro wasn't quite successful, because half of my head was outside the video, so I need to re-record some minutes of this intro, but no matter. The build is going to be DOS and Windows 98 build that handles both early Windows 98, perhaps middle as well. Well, actually probably quite a... Well, depends on the CPU. We just have to test and see what's best for this system. I think it might be the Nehemiah, but then again I might choose Ezra and keep the Dualatin Celeron handy if I need more performance or something. But we'll just have to test and see. What I don't like about this build is that it's ATX, and I'd much rather prefer 80 cases, because I don't like soft power. For instance, it's not really nice on DOS, although with the power management driver, yes, it's not really an issue. I'll of course going to show that eventually, not on this first part though. But the biggest problem is that ATX cases are too big. I'm going to use this case. This is one of the smaller ones. It's not very good looking, but it's not yellowed a bit, and that's really nice. And although it's not so good looking, it has lots of potential. First, let's compare size to the 80 case. Here's a nice one, retrobrighted from 97, although this design is probably earlier, 95 I think. But you can see this is perhaps one drive taller. It's also a bit wider, but that doesn't really matter at all. And the depth, well, some centimeters. This fan also should be taken account for. But this is still one of the smaller ATX cases. If you want to go smaller, well, it would be micro ATX, and that's really not possible for this kind of DOS Windows all-in-one build, because we need ISA slots and PCI slots both. So good thing about this case, it's mostly, well, it tries to be completely screwless design, but these locking mechanisms are not that good, and unfortunately I only got one pair of these drive rails, but I think we'll manage. Oh, and I was told that this case originally belonged to a system with Asus P3B-F motherboard. So same motherboard that we're going to use here. So that's always a nice thing. So this must mean this case is from '99, and indeed it is. Indeed. So it's 99 October that this is made. And this here shows that there's actually 3 5¼ inch drive bays. This bottom one is where you can actually use 3½ inch drive as well, you can choose. So that's actually quite nice, but I'm not going to use because I don't like the appearance of this, especially not that disk drive, and it just makes it look larger than it could be, and I don't just like this. So I'm going to make myself new front bezel during the summer. So this build isn't going to be completed quite soon, but that doesn't really matter. I need the drives in here so I can try out to do measurements and changes and whatever. So it doesn't really matter. We can build the system anyway. But it's from '99, as it should be, because originally there was the Asus P3B-F motherboard. This I removed. It was just here basically, and replaced it with this nicer looking. And I have also replaced the fan, and actually you'll see on the video what I'm going to do about this power supply. I decided to use original power supply, and I think it was good decision, you'll see. But this isn't standard ATX power supply, but that doesn't really matter. It leaves lots of space here, and you can add 12 centimeter fan here. And this is what I'm going to use to cool CPU. I think it's going to be quite nice. And you don't even have to use screws for the cards, because there are these quick mechanisms, and really this case has potential. It's not perfect, it certainly is not, but it has potential. Really, it's too bad that I don't have any more of these. I only got these 2 with this. So to this bottom, you can screw your drive here, but although there are screw holes here, I really don't know the idea, because they don't align with the drives. But these of course do. But I need to make something. But that shouldn't be much of an issue. I can certainly make something. But yeah, I think it's going to be quite nice system. One another reason to make new one is because this doesn't have reset button, and I absolutely hate cases that doesn't have reset. So I'm going to make a reset button, and I'm going to make some sort of speed display, not the usual kind, but rather software configured. But that's for later. Let's see at the end of summer what I came up with. So yeah, this case is now ready to build this, except at some point I'm going to need to repaint this, especially this top part, but not for now, not for now. So now let's look what graphics card I plan to use, and sound cards and everything else. I wanted to try graphics cards that work with 89 MHz RGB. So basically when the motherboard is overclocked to 133 MHz frontside bus. And what I've read and what I already knew, really Nvidia and Voodoo cards are best to handle such heavily overclocked RGB. Well, and I wanted to test if that's true. And I suppose it is, because every Nvidia card I had, and most of them were Nvidia based cards, did indeed work with 89 MHz RGB. And of course this Voodoo 3 worked perfectly as well. And these are period correct cards for this motherboard. Released in '99, just like the motherboard. And this is TNT2. Normal TNT2, not the later higher clocked versions or the bus half MM64, but really full TNT2. And this is Voodoo 3 3000. And really this would be actually quite nice card for this system. And especially if I would simply build the system for the slowest VIA C3 Ezra. But for the faster CPUs, I think something faster will be needed. If I would have had Voodoo 5, I absolutely would have liked to use that one. But I've never had one, and they are so expensive and rare, so I most likely never have one. But yeah, that would have been my choice for this system. But no. If I wouldn't have Voodoo 2, I would use this one. But I have. It's not tested, but let's forget that for now. This absolutely will be benchmarked. This, on the other hand, is period correct upgrade for this motherboard. Released in, what is it, 2000 or 2000? This is 2000, yes. So yes, definitely period correct upgrade. And when I had this motherboard back in the day, I had GeForce 2 MX at one point. It wasn't the MX 200 or 400, but the worst MX. And it was of course overclocked as much as possible, but I would have liked something like this if I could have afforded, and probably the Asus most likely. So this would really be a nice card for this build, except this cooling fan is completely dead and it's beyond repairable. But this is the most likely candidate so far. GeForce 4 Ti 4200, and this is too fast for the Nehemiah. So really, if I want to use those fast dualatins, then yes, perhaps this is the best card. GeForce 4 was the first GeForce where they started to fix those graphics quality issues. All previous Nvidia cards had blurry graphics, 2D graphics. It wasn't sharp and just blurry. But these GeForce 4 cards should be good, and later of course. This has TPOs here. So they doesn't appear to leak, but I really like to recap this, but I don't have anything to replace these, so maybe later. This has the same capacitors as the motherboard. These black ones are Rubicon, same series as was found on the motherboard. These are Sanyo caps, but these are definitely different series than the bad ones on the motherboard. So these capacitors might be really good, but these are questionable, absolutely. But this is likely our card, but can't be sure yet. If the AGP gives issues, I have a backup solution. This is PCI GeForce FX 5500. So this is actually a bit slower than this. And this absolutely has a working cooling fan. This might have good capacitors because for some reason this is built in 2013. 10 years after these chips were relevant. For whatever reason, I don't know. Some Chinese card for some reason. But yeah, it works. And definitely overclocked AGP won't be issue for PCI card, but I'll of course lose PCI slot if I want to use this one. But this is not a bad solution, not at all. And one thing I should mention is the NVIDIA drivers. One good thing about this card is you can use the old drivers. And pretty much, I remember from back in the day, I had to downgrade drivers to play some game. It wasn't really nice experience to just downgrade your drivers and then upgrade for some other game. But yeah, it was like that. But you can use old drivers with this card, compatible for old games. But for this you need 40 point something. That's the optimal for the effect series and good for GeForce 4 series as well. But this is the older AGP 4X GeForce 4 Ti. So I can use 30 point something with these. But even those are too new. You would want something 7 point something that this supports. So for compatibility for oldest games, this is better choice. This on the other hand, you really don't have any reason to use this if you have this one. This is simply to get period correct benchmark results. And I want to see, can the Ezra really even benefit from something faster than this. But the compatibility shouldn't be much of an issue because I'm going to use this Voodoo 2. And this of course can be used to handle of course the Glide games, but also other games as well when two new drivers cause issues for this GeForce cards. And because I have this one, this Voodoo 3 doesn't make much sense. Except the pass-through will always reduce image quality. Some people like to use Matrox cards with this, but of course this is going to reduce the image quality anyway, so you kind of it loses the point why you use Matrox to begin with, because these GeForces have much better VGA compatibility, like Voodoo 3. But we're going to mod this to a mod that improves the image quality. Or if this happens to work, and if it doesn't, well, we'll have to look out why. But pretty much here are the cards we're going to benchmark. There were some others, but the Radeons, well, all the later ones, well, they didn't support, they weren't very good with the overclocked AGP. And all the ones, well, I really wouldn't want to use anything slower than This, well, this is of course lower, but this has other benefits. What about sound cards? Well, I suppose this is the only one you really need. For those at least, and why not for Windows as well. You have Gravis Ultrasound, you have great Sound Blaster Pro compatible Crystal chipset, you have real Yamaha OPL, and you even have MIDI processing unit that supports intelligent mode. And of course the X2GS has real Roland sounds. So this really is all in one. So if I would have had only one ISA, this is what I would have used. But I'm saving this for something else, because there is now 2 ISA slots, and let's make it real interesting. I suppose this is what most would use in this situation. In a way, this is best Sound Blaster for ISA, but really I don't like this that much, although finally bugs are fixed. But then you lose the wavetable connector, no more data ports, no more real Yamaha. But other than that, yeah, not bad card. But still, I would rather use something else. The something else is actually quite easy this time. This is what I'm going to use for Sound Blaster compatibility. This is Terratec EWS64 and XL. And the XL, it means this to be installed to the drive bay. And what you have here is connections, MIDI in and out, 2 of them, digital out, 2 of them, and digital input. And not only that, here you can install full-sized data port like this. So you could have the Yamaha XG compatibility if you want, or you could add real Roland or whatever here. But this is also the weak link, because if you take a close look, some of these letters are wearing out. And I thought maybe I could spray some varnish on top of this, but I would need to clean it first. And if I clean this with IPA, well, maybe I get the letters out. If not, maybe the varnish will damage them. But something needs to be done, because this is going to be, they are going to wear out eventually. And second, I don't really like how this looks. In a way, it is really nice. It's full metal, quite thick one actually. But it's rounded from top and bottom, so, and because the color is what it is, it really doesn't seem to fit to any case. So it's always going to stand out, and I don't think it's going to stand out in very pretty way. And that screw, well, they definitely should have used some other solution. It doesn't look good. I'm definitely going to use this card. This is period correct high-end ISA card. Let's see, date was something somewhere here 98 something. Yeah, there it is, week 32, 98. What this DreamSynth supports is that it supports hardware mixing, and I mean like Gravis ultrasound, so you can this is actually even better to play tracker music than ultrasound plug and play. It supports 64 channels and up to 64 megabytes of memory. And Gravis ultrasound plug and play supports up to 16 megabytes, but those normal cards support only 8 megabytes. And not only it supports hardware mixing for the tracker musics, it's essentially a MIDI synth. And it doesn't have any onboard ROM or sounds, but instead you load to the RAM the sound font, although it doesn't support sound fonts that would be Sound Blaster compatible. It has its own files to be loaded, but among them is actually the Roland copy of Roland sound canvas. Basically Dream recorded Roland sounds from the synth itself and made sound bank that would sound just like the Roland. And there were lawsuits and something was settled and whatever, but it basically sounds real close to the Roland, and of course this also supports all the Roland effects. The crystal, it's very close to the one seen on the Orpheus II. I think this is CS4236B, and it was 37B on the Optical, but I think only it has different 3D sounds. And you have two outputs, line outputs. The second, it's only the DreamSynth, and the output 1, it's configurable, and we also have two line-ins. The line-in 2, it's to the Dream always, and it's high quality 18-bit input, and the line-in 1, that's basically line into the crystal. But this is what I'm going to use, but I think this card deserves proper review. So I'm going to make a separate video just about this card. And we can't use this just yet, because to do those benchmarkings we need real Yamaha OPL 3, because that's very speed sensitive. And I want to test those VIA C3s, how they handle the OPL 3. So this is going to end up in this system, but not just yet, not yet. I'm going to start with this one, CT3930 Sound Blaster 32. And why this? It has real Yamaha OPL in a separate chip. Of course, that's the one reason. But the other reason is that this is the sound card I ended up with when I had that Asus P3B-F motherboard back in the day. I couldn't use my ultrasound anymore, and this was the Sound Blaster I had. And this is what I used. But this might be exactly the same card, but I had two of these at one point, so perhaps I mixed them and I'm not sure. But this could be the very same card I used back in the day. And let's take Gravis ultrasounds next. I could of course use plug and play. That's basically what the Orpheus II has. But I don't need 8 megabytes. Because if I want to just listen to the tracker music, I'm going to use the Terratec card. It's even better in that. But we're of course going to do comparisons. How do they sound any different? But that will be on the separate video where I test the Terratec. But actually, this is the ultrasound I would have liked to use. This is Agas clone of the plug and play. But you can install 16 megabytes here. And this also has very nice feature. There's a jumper that you can output minus 5 volts to the ISA slots in case you have power supply that doesn't output minus 5 volts anymore. So, but I don't need that. Neither do I need 16 megabytes because I have the Terratec card. So it would be kind of waste to use this card here. So if I'm going to use plug and play ultrasound, it would rather be this one. But of course we can test, do this sound any different or not. But really, it would be finally nice to use the very same ultrasound Ace I had back in the day, now with the Asus P3B-F. But this is not the very same card. That card I'm reserving to another build. I'm going to build my 96 computer I bought then. I almost have all the parts for it. But so, this other Ace, it's recap because it has had leaking capacitors, those big ones. But this is what I could use, because really all I need Gravis ultrasound is for games, because I have the Terratec card. So why use either of these? They can be saved for some other system. And this is the easiest and of course 100% compatible with DOS games. If you use ultrasound plug and play, you have to make some fixes. It's not a big deal, but still for some games. But this is the easiest solution. But of course I want to compare. This is a very high quality card. It produces very little noise. Just as low noise as Ultrasound Extreme, and this is known to be good quality. I don't think this is as good quality. Well, of course it has much older chip, but I want to compare, and also it would be nice to compare this to the real one. No, wait, one more thing. I still haven't tested the SBlink, and since the Terratec card doesn't have real OPL3, it has the Crystal FM. Well, I want to use this card in the system just for ESFM. And if I could use this another wavetable connector as well, so who knows, but we'll see. But really, I want this card just for the ESFM, and I'm going to route it to the Terratec card. Both of these Terratec cards, and I think it's how Terratec did this. You have those pin headers right behind all those plugs. So you could internally connect output from here to input from here, just with internal cable alone. But I don't really think is it any better way. But that's possible. And color scheme, they are just the same color, real nice. So I think these are going to fit together quite nicely. One fun fact is that the FM output is disabled by default on this Terratec card. You need to enable it. But it's of course real nice it's disabled by default, just for this purpose. But yeah, this is going to be a nice combination. And of course I'm not going to need the SBlink for the ESFM or MIDI at all. This is only for the Soundbuster support, and we don't actually even need that because this handles everything. And I'm also going to test this. I'm not even considering using this, but just for another card to test the SBlink. Absolutely, we are not done yet. Let's put them here. This is Soundbuster Live, if of course very period correct sound card. PCI sound card for this system. Again, this color scheme would have been really nice here, just like the others, but this is the worst Soundbuster Live, and it looks nicer than the others, of course. And also, I think this came with this card, although I'm not 100% sure, but you could actually use it. And then I have this Live Drive too. This didn't originally belong to this card, that I'm sure of. But I think I retrobrighted this, but it didn't turn out to be better than this. Of course, I can still try another, but I'm always afraid if there are any text here, especially that line in 2, that it's going to wait them away. And I think this looks, even though it's plastic, but I think this looks much better than the Terratec one. But I don't really want 2 of these. And I guess I kind of would like to use this with this very worst Soundbuster Live. Although, I don't know, there's really no point. I'm not going to need this at all if I have the Terratec, that's certainly sure. Although we have optical output, but something like that would have rather be nicer on the back. And here we have MIDI out, MIDI in, coaxial digital sound input and output, and some creative specific digital connector. And you can use all these 3, because you route this somewhere here, and then from here to here. Or you can leave this out and just use these 2. And of course, all of these 3 Soundbuster Lives have that connector. But why do I have 3 models here? Because this CT4830, this is what I bought back in the day. This is my original card that I bought for the system where I had my Asus P3B-F. So it would be quite nice to use this very same card. This was sold as Live 1024, was it? But basically it's really the same card. I think this has some connector, and it does has some more connectors. You have volume control. You can have your digital volume control somewhere, but perhaps I don't know if these are the same. Not necessarily. And then there's the final Soundbuster Live 5.1, but really it simply has the 5.1 output. So yeah, these are of course period correct for this system. I could totally use Soundbuster Live here, but this is going to, I think I could use it, but I would rather save for some other build because I have the Terratec one. Really, the only problem with these cards is that it processes 48 kHz. So everything needs to be resampled to that. But otherwise you want EAX sounds. Many Windows 98 games support it, and it's a real nice card. Let's take another option. Soundbuster Audigy 2001 card. This should have a little bit better sound quality, I think. And I think this will also, it also supports this very same panel if you want to. But other than that, I think it supports EAX. Some later version that this doesn't support. I don't remember how those went. Maybe this was 4 and this was EAX3 up to or whatever. Well, this may sound a bit better, but it still has the same problem. You had some options to override the 16-bit 48 kHz issue, but anything that is processed with hardware, because this always processes 16-bit 48 kHz only. The ODG 2, this is an option as well. It still has the same issue. Everything that's handled in hardware here is resampled to 16-bit 48 kHz, and the resampling, well, it wasn't high quality one. It was the Sonblaster X-Fi that fixed that one. And while this does sound better, and it supports higher sampling rates and such, but that basically means you have ways to override and do things in software and not in hardware. But for games, of course, EAX is always processed with this one, so everything is always resampled. But I think games supported 48 kHz or used already, so it doesn't really matter for games. And if you have BI8 chipset, I think this ODG 2 fixed one of those compatibility issues. So for BI8 chipsets, I think ODG 2 is the way to go for Windows 98 systems. But this is the card I bought back in the day, but this has sound issues now. It's broken. Basically, I think it needs to be recapped. But I read from Wallconcept long ago that it's these 4 22 microfarad capacitors. I think they are the power circuit or something. That these fail. And you should replace them with 47 microfarad capacitors. I think I'm going to use this card simply because I bought it myself back in the day. And we are going to listen how this sounds and then recap only these 4 capacitors and see if that fixes the issue. And if not, well, we can recap everything. But I also have another of these cards that I could use. But I want to use this one because I bought it back in the day. Network card. Well, I think I'm going to try this card. This is 2002, but I think there are still DOS drivers for this card. If not, I'm going to use some older. But this is so small that perhaps I can place this between the NVIDIA card and Voodoo 2 card to leave larger air gap. And I really want DOS support, and that's absolutely requirement. And we already have soldered ROM here. Perhaps it can be replaced with socket if necessary, and who knows what I can do. But yeah, I think this is good for network card. The BX chipset is so old, it only supports HDMI 33. And something like this could be used to fix that. But should I even think of pasting PCI slot? What is? I don't think. You need to use Windows drivers, of course, and this just has its own BIOS. It could be used to overcome some BIOS limitations if necessary. So perhaps this is a good card for some system, but I'd rather not use this here. This is Pentium 3 Cat Core 550 MHz. I had 450 MHz back in the day, and of course I overclocked it as much as I could to 558. And it didn't post at 600, but I didn't even have memory fast enough. But this I want to use as a comparison CPU, and perhaps we could use this 667 Pentium 3 copper mine as well, and maybe one of those that 400 PPGA Celeron as well, just to compare it to the slowest C3. I think that's about it, and of course we are going to overclock those VIAs and Tualatin Celerons as well. But this is a good period correct, second fastest of the time CPU. I even found my manual when I had the Asus P3B-F. I think it was something most likely September 99 when I upgraded to that. This manual revision is 1.01 from July 99. These are not period correct, but it doesn't matter. DVD-ROM drives, and these are the good ones. I mentioned when making the test pens. You can slow it down easily. It supports slowing down with CDPQ. And you can slow it like so that when you change disk, it doesn't reset back to the fast original speed. And these are burnable DVD drives, and this system is fast enough so I can actually burn DVD if I really want to. The other one is broken. Perhaps we could take a look inside, because this front bezel was originally here, but I simply replaced those when this one broke. I'm going to repaint this silver one to the color I'm going to use on my case. And these silver ones are basically already factory painted, so yeah. I don't like silver. Definitely not going to build silver system. But yeah, these NEC drives are really good. Hopefully we can get the other one fixed. But really, here I'm testing 1 GB of memory, and yes, it works. It makes booting speed slower, but that doesn't really matter. And of course, I'm asking trouble. This one works. This is 160 GB Samsung, but I'm going to try this 200 GB Seagate. I don't know. I haven't tested this. I hope it works, but it doesn't really matter. And of course, this cannot use over 128 GB, but that doesn't really matter. Definitely not period correct hard drive, but I want space here, so this is what I'm going to use. And this is for the backup if there's problems with this one. But I suppose we need to take a look at that power supply next. I'm sure you could modify this to use normal ATX power supply without too much effort. But I hope there won't be any need for that. Let's see what it is supposed to output. 15 amps on 3.3 volt rail, 26 amps on 5 volt rail, and 9 amps on 12 volt rail. And of course this is old enough that it supports -5 volts, so no need to modify anything. It hasn't been opened. The warranty sticker is intact. So yes, there's connector for the fan. That's always good. Yeah, bearings doesn't sound too good. Definitely this fan at least needs service. 99, weak 50, but no pulsing capacitors here. Those blue ones are T-pose. But let's get this out of here and look closer. Those may not be bad T-pose, but I don't want to left any depots in this system. Yes, that's about it. This PCB, it actually doesn't look practically any different than you would expect from an ATX. Perhaps this even goes to standard ATX inside ATX power supplies. Perhaps you could actually use this one if you want to replace power supply and simply find compatible PCB. Even though the capacitors look okay, but there's something else to note. This glue. This yellow glue, it's the glue that turns conductive eventually. It turns more and more yellow and it eventually starts to conduct, and that's what's going to kill the power supply if capacitors doesn't do that first. But good thing is that there's quite little of this. There's a little bit here as well, but those won't matter at all. But here, I don't know, it probably doesn't see quite well on the camera. Let me try to move this up. You can see it's not as dark as here yet, or here, but that will cause some issues eventually. Since we are on the mains side here, and it will be a nasty sort eventually. So that blob of glue needs to be removed. Actually, this isn't such bad. I think perhaps I can remove it without desoldering those capacitors. I'll just have to try and see. But this is not a recapping video. So I think I recap this off camera, and we'll just have to check are those capacitors bad or not. They look good, but those are depots, but not green ones. And here. You can see the glue is yellow here, but here it's completely brown and very hard, but quite brittle actually here. I think it looks almost burnt, and I think that resistor should be tested, and this capacitor is most likely bad because this resistor has heated this quite badly, I'm sure. And I think I should at least desolder this resistor completely and try to place it away from that capacitor. But if this is temperature sensor, I'd say it's in good position at least. But yeah, I'll recap this and we'll take a look later. I haven't recapped anything yet, but I have to show you something. Let's put this aside just for a while. We'll take a look at it soon. But when scraping this glue, I don't think you can see, but the coating of that resistor came off and it's rusted under it. And there's also another evidence that there's actually very bad looking blob I missed before. that absolutely needs to be removed. And that's brown brown resistor leg. Sure, and yes. So looks like that glue corrodes, but how the heck it corroded under this resistor coating, that I can't be sure, but it somehow has gotten inside it. And so I took another power supply. This is Nexus from the 5 volt era. This is PV power supply, and it also has -5 volt, and not much on 12 volt, but more than this one, and 30 amps on +5 volt. So yeah, this would have been even better. And this PCB doesn't quite fit inside normal ATX power supply, almost, but not quite. But you definitely could get one of these inside this, as long as it's not too tall like this is. But this has depots as well. Yes, I'm bulging one at least, but that's not the issue. It also has this glue, and it's all over the place. And that glue has started to corrode. Very hard to move this. Corrode this metal case. So this glue definitely corrodes metal. And I don't know if this power supply needs so much work. I'm sure it's better, but there's glue everywhere. Below capacitors, over them, everywhere, and it's gotten in much worse condition than this one. But yeah, that glue is a real killer. Bad capacitors aren't nowhere near that much of an issue. It's easy to replace them, but if they're glued, and if this whole power supply is surrounded by, covered with corrosive glue that turns conductive, and real bad. What power supplies I have are pretty much like this, or from the +12 volt era. So perhaps this is the easiest. This is my third Nexus, and the other two are a bit newer, I think, but they're just as bad. Depots, glue. Yeah. I don't think perhaps that would help identify the real manufacturer. Do not buy Nexus power supplies for your retro system. So yeah, I'd say this is for now the best bet. So the power supply is now recapped, and let's take a look. I had to desolder some components, resistors here to get all the glue off, but that wasn't hard. The resistor checked okay, but I replaced it anyway, and there's also another location. This was the bad one. It has the blob of glue was burnt, and I thought maybe this power supply has been sorted, and that's the reason for the burn. But that fuse checked okay, and there's the temperature sensor. Well, I couldn't scrape all the glue off. I took what I could, so I ended up using hot glue to glue it about where it was. And this is the big resistor that had corroded, but it checked okay. I would have replaced it, but I didn't have replacement. So I placed a heat shrink around it just in case. Maybe it helps, maybe it doesn't, but at least I did something. And now you can see there's some glue on these 3 coils. Well, here where the burn, actually it was there. Burn was here, but that was also quite bad. Blob on the other side. Well, it was on that small coil, and I think getting the glue off also took what varnish was on top of the coil windings, and I placed PCB varnish just in case on top of that coil. But I don't know the values. I don't have schematics what is power supply, so I don't know replacements what is, so I think it's best to leave these alone. These won't cause shorts. But of course, if it turns, and it will eventually turn to corrosive, then it will damage this anyway. So yeah, there's simply no gentle way to remove that glue. So since I don't have any better ideas what to do at the moment, it's better to leave them as is at the moment and at least try this power supply if it even works. And let's take a look at these capacitors. I haven't tested them yet, but no leaking capacitors, no bulging capacitors or anything. These big smoothing capacitors, there were 200 microfarads, 6.3 volts. I think these are for the 3.3 volt rail, because there were also 3300, 2 of these 10 volts, so these must be for the 5 volt rail, and one of these 22 microfarad 16 volts, so I think this is for the 12 volt rail. And we also had some 470 microfarad capacitors, 2 16 volts and 1 10 volt. They were this one and that one and that one. But I didn't check what was the 10 volt one. And then there's the smaller capacitors. But I didn't have perfect replacement. So these, for the 3.3 volt rail, I replaced with 33 microfarad 6.3 volts. These two, I think they were, yes, these two. And these for the 5 volt rail, 3300. Well, there's now 4700 microfarads in place. No, the other one is actually the same, 3310 volts, but the other is 4700, because this other one, when I removed the capacitor, you could see that there was place for larger diameter of this. I think this is 12 millimeter, and this is 10, I think. So since there was space for the larger one, I just used larger one here. I didn't have enough of this 3300s anyway, so that's larger. And this 2200 microfarad 16 volt, well, I would have had just one of those I could have used, but I replaced it with 4700 microfarad 16 volt capacitor. We'll just see what happens. Of course, it should be even smoother, but if these take longer to charge, maybe there is some timeout circuit, who knows. But you'd think that smoothing capacitors bigger is better. And since I didn't have any of these 470 microfarad that I would have placed in power supplies. I had those audio or sound cards, but they are rated for 85 Celsius, and these are all 105 Celsius capacitors. So I used 1000 microfarad caps for these three. So yeah, let's measure a couple. And these, I removed this one and measured it off camera, and it was completely fine. They are both 470 microfarad, 200 volt. And when this was removed, I tested this on circuit, and it pretty much measured the same. So these two big ones are not replaced, but they seem to be okay. Now let's try this 22 microfarad 16 volt. Yes, 1 ohm. But otherwise, I think this is okay. Perhaps this isn't low ESR capacitor, so perhaps it's fine. 3300s that were on 5 volt rail. Yes, this is okay, and this is low ESR. Now let's take one of these from the 3 volt rail. Yeah, ESR is big. A bit higher, 0.0 ohms. But this, yes, it otherwise is okay. Yes, it was 22 and not 33. So I'd say it's okay. Let's take that 10 volt 470. This could be from the coil, but then again it could be, yes, it must be this one. ESR 1.8 ohms. Yes, this is a bad capacitor, 270 microfarads, even less. So I'd say this capacitor is cooked, and that's certainly the point where there's much heat. Well, actually, I'm testing this off camera and report if there's something to report. All the small capacitors, they're good, but they are not low ESR, not a single one of them. But they are all rated for 105 Celsius. So, and also, these are okay. All the blue T-posts are okay. It's just that this one, Suscon, 470 microfarad 10 volt capacitor, this is cooked. This capacitance is way below what it should be. And this is certainly a bad capacitor. And this is questionable because capacitance measures okay, but ESR, this isn't low ESR like all the other smoothing capacitors. So you'd think this would be low ESR as well. But if not, then it's okay. But if it should be low ESR, then this is starting to go bad. So 1 or 2 bad capacitors here. But really, the glue was the biggest issue, because it already had started to do some damage. But now, I think this should be put back together and test. I removed this cooling fan. I'm not going to service this. Perhaps it's serviceable, but it doesn't sound too good. I have this fractal design that sounds really quiet. No noise from the bearings at all. This goes over here, but I could replace this with something nicer looking as well. Are we ready? But let's plug the fan so you can see it works. Broken hard drive has a load. It started, but first let's check our voltages. Let's start with 12 volt, 11.7 volts, and 5 volt, 5.17. Very good. It probably drops a bit after we place load, but is it minus 12, this blue one? Yes, it is minus 11.4. What about this gray wire? Perhaps that's 4 point. Is it power good? I don't remember. But it certainly is good value. Then the white must be minus 5 volt. Yes, it is. It is. Very good, very good. Yes, looks promising. Certainly does. What about ripple? Can we measure it somehow? Let's try. Because that's the most important one. Alright, I've tried to measure ripple, but I think this scope simply isn't good enough for that. You're supposed to set some 20 megahertz or bandwidth limitation or something when measuring ripple, but this doesn't seem to have that. And you should also use that 10x setting on the probe, but well, you can even see less. So now it's 1x and I'm on 5 volt rail now. And 50 millivolts per square. And if I change, it's now 500 millisecond, and if I change this to 200 millisecond, well, I can't measure anything at all. So looks like this is the best I can do. And according to this, it's usually 20 millivolts, occasionally less, occasionally a bit more. But this isn't really accurate way. But perhaps we can compare to the bad power supply. But for ATX power supplies, you should, at least these old ones, well, perhaps new ones as well, I don't know. But maximum is 50 millivolts of ripple for 3.3 and 5 volt rails, and 140 millivolts for the 12 volt rail. So if we can believe this, I guess I could at least double this to be sure. Well, then the 5 volt rail is now okay, but this isn't accurate. It certainly is not. So let's measure 12 volt. Our 12 volt rail is noisier, and that was completely expected because the specification allows almost 3 times ripple for 12 volt rail. But we're still under 50 millivolts. But what about the 3 volt? That's really hard, really hard. I don't have anything to easily measure 3 volts at the moment. So we're going to measure 3 volts with all the load. I think this is good enough that I can build a system with this power supply. But I'll make something and we'll measure that later. But at least what we now can do is compare to the other power supply that I've been using when fixing the motherboard and testing it and things like that. I made something like this so I can measure 12 volt and 5 volt and there's ground connection. How much voltage does the fan get? Because I think this is temperature controlled, but to be absolutely sure I want to measure it. Let's power it on again. And see how much voltage we got here. Okay, these are now wrong way, but that doesn't matter. 10 volts. I'll remove this hard drive for now and test how noisy the original fan is. Quite noisy, not as noisy as the hard drive, but this has dried bearings, so it would need service. This pushes air quite a lot actually, as expected. But this new one, that's a lot quieter. Maybe it would even be better if I simply set it to constantly 12 volts. This is the 2016 power supply that only has single 12 volt rail and lots of amps on plus 5 volt. But at least it didn't have that glue. Are these thinner, these wires? They look, yes, they are 20 AWG. Yeah, that's also a sign from bad power supply if they use thinner wires, and this one certainly does. Now that's better. Well, that doesn't look good at all. There's those spikes. Now it stables a bit, but still. Occasionally those spikes. And I still can't measure anything if I set this to 200 milliseconds. Well, actually it can something. But those spikes are horrible. What if I set this to 10x? Yeah, still this scope simply can't do. Let's measure with the exact same settings. I measured the other one, but there's those spikes. Those are absolutely horrible. Remember the other power supply was usually about 20 millivolts, occasionally 24, and no spikes. But this is absolutely horrible. Let's take the 12 volt. Still those spikes, but it's otherwise better. Let's go to the 5 volt again. This may be a lot newer. Even 500 watts it says. But especially after I replaced the other one's capacitors and made some changes, added bigger smoothing capacitors. Well, it didn't do things like that. It was much better. This I won't use anymore, that's for sure. And I knew it was bad, but this bad. This old power supply is what we're going to use. I'm still not sure about that fan. It may be enough, and that this is silent at least, and that's always positive. But heat kills those capacitors. So but I would believe this is a good one. If not, I just have to buy another 92mm fan. So this is what we're going to use. Old power supply, now recapped, and with somewhat bigger smoothing capacitors. But I think this is good moment to stop and continue on the part 2, because I need to install Windows and find drivers for all those cards we are going to test. And thank you for watching. Please leave comments if you think this wasn't set properly, or if there is something I could do to measure the ripple even better, or if you think my selection of parts for the system isn't good for some reason, or perhaps you want something specific for comparison. But yeah, thank you for watching and see you on the next part.